Hello students, welcome once again to Solochem Lab. As usual, we have a 2021 UTME problem on the board to be solved. The problem is on organic chemistry. The problem goes this way. A red precipitate of copper 1 carbide is formed when ammonium solution of copper 1 chloride is introduced into, we have some options given to us. Option A, we have option A given to us as 1, 2, 3, 4 as butane, but2-ine. We have option B as but1-ine as 1, 2, 3, 4, but1-ine. I call this option but2-ine because the triple bond, the triple carbon-carbon triple bond is at position 2, 1, 2. And then this I call it but1-ine because the carbon-carbon triple bond is positioned at carbon atom number 1. So I call it but1-ine, but2-ine, and then this one, 1, 2, 3, 4, is but1-ene. The carbon-carbon double bond here is positioned at carbon atom number 1 according to IUPAC. You remember, IUPAC means International Union of Pure and Applied Chemistry. And according to the rule of IUPAC, the position you will give to the carbon-carbon double bond, that's the functional group, should be the lowest possible position. If you count from here, 1, 2, 3, the carbon-carbon atom is at position 3. If you count from here, 1, 2, 3, 4, the first place you meet the carbon-carbon double bond is at position 1. So we take that lower position. The lowest possible position of the functional group is what we take. And then this last one, 1, 2, 3, 4 carbon atoms, butene, no double bond, no triple bond, so we call it a saturated hydrocarbon. The name, the suffix would be ANE, butane, normal butane. Which of them will give us this precipitate? A reaction has been illustrated, and in the reaction we have a terminal alkyne reacting with copper 1 chloride to give us a precipitate, a terminal alkyne. What is a terminal alkyne? A terminal alkyne is an alkyne which has its carbon-carbon triple bond at the end at position 1. Look at option A. It is an alkyne, but the carbon-carbon triple bond, is it at position 1? Count from here, from the left. 1, 2 is at position 2. Count from right. 1, 2 is at position 2. Is this option A terminal alkyne? No, it is not a terminal alkyne. Therefore, it's not the correct option. It's not going to give us this precipitate. Do we have another alkyne here? Yes, that's option B. Let's check. Is it a terminal alkyne? That is, the carbon-carbon triple bond, is it at position 1? Let us check. 1, 2, 3. If we count from left. Then counting from right. 1. Is this a terminal alkyne? Yes, it is a terminal alkyne. Therefore, we expect this terminal alkyne to give us this reaction, this precipitate. This is the correct option. Remember, a precipitate is a solid that comes out, a solid that forms in a solution when you add 2 or more reagents together. When you have a reagent and you drop in another reagent into it, if a solid forms, that solid is called a precipitate, and you can visibly see it. You can remove that solid from the mixture by filtration. This reaction illustrated on the board is called a substitution reaction. Do you remember what the substitution reaction is? It's a type of reaction where an atom or a group of atoms replace, that is, they push out and take the place of another atom or group of atoms. That's the kind of reaction we have here, a substitution reaction. It is carried out by terminal alkynes. Don't forget, alkynes are unsaturated hydrocarbons. Unsaturated means that they have either triple bond or double bond. Any hydrocarbon that has a triple bond or a double bond is called an unsaturated hydrocarbon. If it is an unsaturated hydrocarbon, it is known to undergo an addition reaction. But in addition to that, terminal alkynes also undergo substitution reaction to give us this product. In our subsequent classes, we'll talk more about addition reactions and substitution reaction. But for now, the correct option on the board is option B. It is a terminal alkyne. The other alkyne we have here is not a terminal alkyne. It will not give us this substitution product. It will not give us this reaction on the board. And the other two options, this is an alkene, so we don't consider it here. This is an alkane, we don't consider it here. Do you understand? Do you still have any question? Feel free to drop the question at the comment section of this video so that in our subsequent classes we can examine the question you have dropped. Thank you. Bye for now.